All right. So now let us do an expansion of 1. Okay? So let's say that we want to find, let's do part A. Find the Maclaurin series expansion of f of x equal to e to the x. Okay, the minute they say Maclaurin series, what does that indicate to us? That indicates that our a is equal to 0. Okay, that's what that indicates to us. Okay, so what do we need to do? Well, if I look back at my formula that I had before, here's my expansion. What am I going to need? I'm going to need to have the function evaluated at 0. I'm going to need the first derivative evaluated at 0, second derivative evaluated at 0, and so on and so forth. And luckily, the first, second, and third derivative and all the other derivatives are very easy of this guy, right? So let's do that really quickly. Other problems, not as easy, but. Okay, so here's f of x. It is equal to e to the x. F prime of x is equal to e to the x. F double prime of x is equal to e to the x. F triple prime of x is equal to e to the x, and so on and so forth. But now we need them all evaluated when x is 0, right? So, I'm going to have f of 0 is equal to e to the 0, which is 1. F prime of 0 is equal to 1. F double prime of 0 is equal to 1. And F triple prime of 0 is equal to 1. So easy. I'm going to put 1 in this spot, this spot, this spot, and that spot. And every other spot. Okay? That is the first part of my expansion. Now I just need to follow the formula. So that means that this is going to be f of x is equal to e to the x, which my expansion is going to be f of 0, 1. Actually, let me do it like this. F of 0 plus f prime of 0 divided by 1 factorial x to the first power. Let's do it this way first. Plus dot, dot, dot. Oh, darn it. All right, so now let's substitute it in. So this is, f of 0 is 1 plus, that's 1 over 1. So that's just going to be x plus 1/2 x squared plus 1/6 x to the third, right? Plus, let me do the next one. This is going to be 4 factorial. What's 4 factorial? 24? 1 over 24 x to the 4 plus dot, 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 and so on and so forth. So that is the answer to the question. This is the expansion. Suppose it asks for part B. Suppose it asks for the written as a sum. Find f of x to e to the x as a sum of a power series. If I want to write it in summation notation, it wouldn't be exactly this guy because this is general for everything. I want to find one that is unique to just this. So what do I do? Okay, well, this is 1. This coefficient is 1 also. This coefficient is 1/2. This is 1/6. but this is 2 factorial. This is 1 over 3 factorial. This is 1 over 4 factorial, and so on and so forth. So that means then that f of x equal to e to the x is equal to the sum n equal to 0 to infinity. What are my unique coefficients for this power series? 1 over n factorial. That is my coefficient. These are my CNs. And then times x to the n. That's what this is written as, a power series. E to the x is equal to this expansion. Okay. Let's do a part C. Let's find the ratio of radius of convergence. So in this situation, we would do the ratio test, right? So we will go, okay, I'm going to take the limit as n goes to infinity. And I'm going to do the n plus 1. So this is going to be x to the n plus 1 divided by n plus 1 factorial. And this is going to be x to the n divided by n factorial. And what does that equal to? When I multiply by the reciprocal, I'm going to have limit as n goes to infinity. And when I cancel things out, I'm going to have an n plus 1 left in the denominator and an x left in my numerator. And I want this to be less than 1. This is what I want. I want to solve for this equation. Well, I know that I can pull out this absolute value of x, and I'm going to have a limit as n goes to infinity of absolute value n plus 1. And I want this to be, less than 1. And I know that this is going to go to 0. So what do I have? Absolute value of x times 0 is less than 1. Well, that means that no matter what x is, this is always going to be equal to 0. So since it doesn't matter what x is, then our radius of convergence is equal to infinity because all the x's can converge. And if I wanted to do my interval of convergence, then it will be from negative infinity to infinity. Like so. All right. Let's pause.